Now, welcome to today's class. Today I want to take you through a complete question under calculus. Now, there are several questions that are categorical. The first question is here with me here. Now, you've been told that the distance moved by a particle is given by, so displacement s is equals to t cubed minus 6t squared plus 9t plus 60 meters. So the question 1 states that find the displacement of the particle after 2 seconds. So this question number 1 is very simple. What you do, just go to the displacement here, then where there's a t, which is time, just substitute with the 2, then you shall have done. So here I'll just say that s, which is displacement, is equals to now 2, it is cube, because t is cube, so 2 cube minus 6, that is 2 because it is 60 squared, so 2 is squared there, then plus 9 into 2 because it is 90 and t is 2, then lastly plus 60, which is a constant here. So when you do that, you shall be having 62, but remember displacement is in meters, so 62 meters. Then assume you've been given the second question, because that is question A. Now question B here, you've been told that to find the velocity when t is equals to 4. Now what you do, so as to derive velocity, you are supposed to differentiate displacement so as to get the velocity. So here, since you've been given displacement equation, just differentiate the equation so as to get velocity. So you shall come up and say that ds dt is equals to velocity, and what is it now? Just differentiate this. So when you differentiate this, you shall come up with 3t squared. Remember, you just take the power, then you subtract 1. Take the power here, subtract 1, that way. So minus, so 2 by 6, that is 12. When you subtract 2 minus 1, that is just 1. Then I have plus 9. Remember, there I'll be having 0. Now after this, we've been told that when t is 4, so where t is here, I'll just substitute with 4 and I shall have done. So I'll come up and say that is 3 into 4 squared, because it is 2 squared, minus 12 into 4 there, then plus 9, whereby when you find out the result here, you shall come up with 9 meter per second, because displacement is meter per second. So that one you shall have done there. Then, because I've told you that I'm giving you the complete question under calculus, question 3, assume now we've been given that the acceleration now when t is 5. Now, since we've been given here the velocity, equation of the velocity here, that a velocity now is equals to 3t squared minus 12t plus 9. I'll just differentiate this to get acceleration. So that's what I do. So I'll just come and say velocity is equals to 3t squared minus 12t plus 9. So to derive acceleration from velocity, I'll just say dv dt, obvious is acceleration, and now what is it? I just differentiate this. So when you differentiate this, you shall come up with 6, that is t minus 12, because there is a 0 there. Now since t is 5 here, I'll just substitute where t is, just substitute with 5, and there I'll come up with 6 into 5 minus 12. So when you take that 6 by 5, that is 30, minus 12, that is 18. So I'll come up with 18 meter, but it is per second square. Acceleration, that is in meter per second square now. Now that is question C. Now let us look at question D here. Now question D, now you've been told that now when the particle is momentarily at rest, then NB you need to be knowing is that at rest, the velocity is always equals to 0. That is the only concept you are supposed to be knowing. Now, since we've known here that the equation of velocity is equals to 3t squared minus 12t plus 9, I'll just equate this to 0, because v is 0. So I'll be getting 0 is equals to the rest here. And that's what I do. So I'll now say velocity is equals to 0. And what is that velocity? Velocity is 3t squared, remember, and minus 12t plus 9. Now, since v is equals to 0, which is this, I'll just say now 0 is equals to this. Then I work out the t. So I'll come up with 0 now is equals to 3t squared minus 12t plus 9 there. Now since this, I can as well reduce it by dividing both each term and every term by 3. I divide by 3, I divide by 3 there. So that I remain with here is 4, here is 3. So that the next step shall be 0 is equals to t squared minus 4t plus 3. Now from here I can use several methods to work out the value of t. First of all, you can use that is a quadratic formula, you can as well use completing square method, or you can use the simplest one, that is product sum method. So as per now, let us look at product sum method to solve the value of t. The formula states that you are supposed to equate everything to 0. Remember, the equation is 0 is equals to, so let 0 cross the equal sign, then the rest come the other side round. So it will be t squared minus 4t plus 3 is equals to 0 there. Now after that, under product sum method, you are supposed to get the product as well as the sum there. Now product is always a c, sum is b. Now what is AC? AC, I'll just come up, A is the coefficient of t squared. So the coefficient of t squared here is 1. Then C is a constant, that is 3. So 1 by 3, obviously that is 3 there. Then B is the coefficient of t, and the coefficient of t there is just negative 4. After this, I'm required to get the two numbers, which when I multiply I get 3, but when I add I get negative 4. And the possible two numbers there are negative 3 and negative 1, such that when I get the product negative 3 by negative 1, the negative goes, I'll be remaining with 3. The negative 3 plus negative 1 is negative 4, and therefore the two values, they are satisfied. Now after that, I'll just substitute the two values where b is. Now I'll come and say now that is t squared minus, remember I'm having negative 3 by t, that is negative 3t. So negative 3t. Then now come here. So negative 1 by t, obviously is negative 1t, which is negative t. So minus t there. Then I have a constant here, that is plus 3, obviously equals to 0 there. So the next step, you are required to group them into 2. Just group them into 2. Thereby, I'll group this one into 2 that way, then the other one into 2. So you look at the common terms inside the bracket, then you put them outside the bracket now. So the common term here is t, so I'll come up with the t into. So t goes into t squared, obviously is t. T goes into negative 3t. How many times? That is negative 3. So I'll come here and write negative 3 there. After finish up with the first bracket, you move to the second bracket and do the same. So here I'll come up with write negative 1 there, because negative 1 that is the common term there. Then negative 1, obviously if I solve that bracket there, I'll be remaining with now t minus 3. So the sign will change, the sign of positive 3 will change because of the negative here. So that one is equal to 0. Now after this, you are supposed to group those content outside the bracket together. Then you take one bracket only, because the contents within the brackets are the same. So I'll just take one bracket there. So I'll come up with t. Remember, t and negative 1 are outside, so I'll group them together. Minus 1 now. Then the content inside the bracket, I'll take one bracket. So I'll come up with in bracket, so t minus 3 there is equals to 0. Now since I have these two brackets, I'm supposed to use each and every bracket independently to get the values of t. So when I start with the t minus 1, I'll just say now t minus 1 is equals to 0. Then from here I can get the value of t by letting negative 1 to cross the equal sign there, so that I'll remain with the t now is equals to, when a negative crosses the equal sign, it will be a positive. So I'll end up getting positive 1. So the first time is 1 second. So to get the second time, I'll be concentrating on the second bracket, that is t minus 3 are equated to 0. So I'll come and say now t minus 3 there is equals to 0, and from here obvious I can get the time by letting negative 3 to cross the equal sign, so that I'll remain with the t is equals to when a negative crosses the equal sign, obvious is a positive, so I'll end up by getting that is 3 seconds. So the possible times when the particle is momentarily at rest, I'll be remaining with time is equals to 1 second or 3 seconds, and that is all you can do there. So that is the solution there. Now that is, remember, that is question D. Now let us look at question E, so that we can see how we can solve that. Now when we look at question E here, we've been told to get the maximum distance moved. Now the maximum distance moved, and remember NB here should be at maximum distance. We shall be concentrating on those time when the body was at rest. And remember, we've gotten the time as t is equals to 1 or 3. So I'll be using the 1 second or 3 second, so that I can compare the distance between the two. I'll not only take the maximum distance. So if it will be at 1, then I'll just take that one. If it will be at 3, I'll just concentrate on that. And remember, on the beginning we said that the equation of the that is the equation of the displacement. Remember, we began by getting the equation of the displacement, whereby we said that S, remember, the equation of displacement was S is equals to t cube minus 6t squared plus 9t plus 60. Remember, everything was in meters. So this is the equation of the displacement. So we shall be using this by substituting. For the first time we shall substitute t with 1, then we get this displacement there. Then we compare when t is now 3, we get the displacement, so that we can compare both two displacements to get the maximum one. Now let's start by getting now when t is equals to 3, so that we can get the displacement there. So what is S, which is the displacement when t is equals to 3? So I'll just substitute where t is, just substitute with 3 there, so that I'll come here and say 3 now. Remember, t is 3, so 3 cube, so 3 cube there, minus 6 into 3 squared there, plus 9 into 3 plus 60. Now when you work out this, the solution here, when you work out, obviously you will come up with let us see when you dial that. So when I get 3 cube minus 6, that is into 3 squared, plus, that is 27, because 9 by 3 is 27, plus 60, I'll be getting 60. So in these 3 seconds, I'll be getting 60 meters. Now for the second round, now let us look at when t is equals to 1 second. So what is displacement there? So displacement shall be now 1, instead of me having 3 cube, it will be 1 cube. So it will be 1 cube minus, so it is 6 into 1 squared, so that is what I write. So 6 into 1 squared there. Remember to put that bracket. Then after that, remember, after that I'll now come to now 90, and it is 1, so I'll get 9 into 1, then plus 60 there. So when you display this on here, I'll be having 1 cube, so 1 cube there minus 6 into 1 square, that is just 6, then plus 9 into 1, that is just 9, so just plus 9 plus 60, which is a constant there, I'll be having 64 meters. So when you compare the two displacement, 60 and 64, you realize that 64 is bigger than 60, and therefore the maximum distance here, I'll come up with the maximum, therefore it shall be 64 meters as my final answer there. So that's how we can derive that. So you ensure that you compare both the times, because you don't assume that it must be when t is 1. Sometimes the maximum distance might be when t is 3. So you must compare the two first, is when you come up with the final answer. Now that is question E. Now let us look at the next, that is question F, so that we can see how we can solve the problem. So here with me I have, now the question is, find the initial acceleration. Find the initial acceleration. Now back there, remember we had the equation of acceleration whereby we said that acceleration from from the velocity was acceleration was equals to that is 6t minus 12. Remember, this is the equation we were having back there. Now, having given this, now we've been told that the initial acceleration nb should be, that is nb here should be at initial acceleration, the time is always 0. So what I'll do, where t is, I'll just substitute 0 with 0. So like here I have 60 and t is 0, so I'll just put 0 in bracket, of which I'll be remaining with 6 into 0 minus 12. So that's what I write. Therefore acceleration shall be 6 into 0 there minus 12. Thereby I'll come up with 6 by 0 is just 0. So 0 minus 12, that is negative 12. So I'll come up with having negative 12 meter per second square. Remember, acceleration is measured in meter per second squared. That is as simple as such. So that is question F. Now let us look at the G part of the question so that we can see now how we can solve that. So here with me I have two possible ways of setting the equation G. The first side I have maximum speed attained stroke minimum velocity of the particle. Remember, the solutions to the two problems are the same. That's why I've summarized it with a stroke there. If you know how to get maximum speed attained, the same way you will apply on getting the minimum velocity of the particle. That is it. And remember, there is an NB there that at maximum speed or minimum velocity, acceleration is always 0. So NB here should be acceleration is equals to 0. That is it. So since we already have the equation of acceleration as acceleration was equals to 6t minus 12, and already acceleration is 0. So where a is, I'll just substitute with 0, then I get time. So that is 0, because acceleration is 0, is equals to 6t minus 12. After this, now I'll let negative 12 to cross the equal sign there. Thereby I'll be having 12 now is equals to 6t there. To remain with the t here, I'll divide here by 6 and divide here by 6, so that 6 goes to remain with the t, 6 goes there, that is 2. So at maximum speed or minimum velocity, t is equals to 2, so it is 2 seconds there. Now the equation was maximum speed or minimum velocity. Speed is just a velocity. So I'll just get the equation of the velocity which I was having there, then I substitute where t is, I'll just substitute with 2, then I shall just be done there. Now remember, the equation of velocity back there, we said velocity was equals to 3t squared minus 12t plus 9. So this is the equation of the velocity. Now when t is equals to 2, now what is v? So I'll just substitute there. So it is will be 3 into 2 squared minus 12 into 2 plus 9. When you display this in the screen, you shall end up by getting negative 3 meter per second. And therefore, at maximum speed attained or minimum velocity of the particle, the velocity is negative 3. And that's the solution to that. So whichever question, you are supposed to use this, the solution I've given there. Now that is G. Now let us look at F, how we can solve F. Now here, you've been told to find the initial velocity. You are supposed to get the initial velocity. So NB here, we should guide you is that at initial velocity t is equals to 0. Remember, the starting time t is always equals to 0. So what to do is very simple. Since you have the equation of the velocity, you are supposed to substitute t with 0. Then you shall have just done. Remember, the equation of velocity was, that is 3t squared minus, that is 12t plus 9, because we've done it severally. Now when t is 0, substitute with 0 there, I'll remain with 3 into 0 squared minus 12, 0 plus 9 there. Now any number when you multiply by 0 is just 0. So here I'll just end up by remaining with 9 meter per second. Just simple as such. Now that is h. It is very simple, there is no elaboration there. So now let us look at the next bit of it. How now can we solve the last bit of the equation? Now the last bit of the equation is find the distance moved during the third second. Find the distance moved during the third second. Now for a particle to move during the third second, that one means it will move from second to third, and therefore we shall compare the distance now when t is equals to 3 minus when t is equals to 2, so that we can get the distance in between, and that shall be the result there. And therefore we shall concentrate when t is equals to 3 and when t is equals to 2, because it is moving from 2 to 3. Now remember, our displacement back there was t cube minus 6t squared plus 9t plus 60 meters. Now for me to get the distance, I'll just say now 6, let me write the equation first. So that is t cube minus 6t squared plus 9t plus 60 there. Then I compare the two time. Now when 3, because 3 is bigger than 2, I'll put it up there, then 2, I'll now put it down there. Now when I substitute t with the 3, what will I be having? So when I substitute, I'll be having, that is 3 cube minus 6 into 3 squared plus 6, no, sorry, that is 9, that is 9 into 3. Remember, it is 9t and t is 3, so 9 into 3 plus 60. Work out this. Then remember, I've said we are comparing, so we are subtracting with the t is equals to 2. So this side here, I'll now substitute t with the 2. Remember, t is 2 now. So I'll come here and say now 2 cube, instead of me having 3 cube, I'll be having 2 cube now, minus, now here it is 6t squared. So I'll be having, that is 6 into, my t is 2, so 2 squared plus 9t, t is 2, so 9 into 2, that is plus 60 there, because 60 is just constant there. So when you work out this, 3 cube minus 6 into 3 squared plus 9 into 3 plus 60, you will end up by having 60 minus, when you work out 2 cube minus 6 into 2 squared plus 9 into 2 plus 60, here we will end up by 62. Now when you compare 60 minus 62, that is negative 2. Now remember, we were concentrating on getting the distance. When you get a negative, you don't just leave the answer there. You are supposed to end up by ignoring the negative there, and you now say the final answer is now 2 meters. If you leave here, you will be missing 1 mark. So you end up here by saying now it is 2 meters. So friends, having gotten the concept I've given you there, that one marks the complete question under calculus that will enable you to pass with flying colors concerning that is paper 1. It is automatic that it must be, if not 10 marks, it is 14 marks. Otherwise, See you in the next class. Bye.